Optically pure 2-octylsulfonate was treated with varying mixture of water and dioxane, and the optical purity of the resulting product 2-octanol was found to vary with the ratio of water to dioxane as shown in the following table. This is a table. Given that dioxane possesses fairly nucleophilic, this is important piece, fairly nucleophilic oxygen atoms, provide a complete mechanism that explains the variation in the product's optical purity due to the change in solvent composition. So let's take a look at the ratio here, water to dioxane. When we have purely only water, we expect the just inverted octylsulfonate that became octanol. That's because we have SN2. So in case you didn't know, the stereochemistry is telling us that this has to be SN2. We have an inversion going on. And when we add more dioxane, you see that reagent there, somehow the optically pure S2-octanol is decreasing. And that just implies that we have more R structure, R2-octanol. Well, if I show you, first of all, the very optically pure 100% water, I mean that's easy because in SN2 reaction, we have water that attacks one, two, three, four, 1, 2, 3, 4, okay, and okay, we have a leaving group, Ch.7. Water with a lone pair is gonna attack that alpha carbon, and we're gonna have a concerted process in which the leaving group leaves. So this happens simultaneously due to the SN2 nature. And you have to remember, oh, don't forget the stereochemistry. There's a wedge shape bond, and we're gonna have a dash in SN2. And remember that another water comes and act as a base. Okay, so we have this S2-octanol. However, when we introduce dioxane, it can be intermediate leaving group. In other words, this will be temporary leaving group. So he will still act as a what? Nucleophile, because we have 2 oxygen with a lone pair next to it, and also the direction said they are fairly nucleophilic oxygen. So when you add them, he can first act as a nucleophile, and what happens is that he's gonna initially form the bond with the inverted stereochemistry, and it looks like, okay, it looks like this. Okay, I will draw the arrow. He comes and then this leaves. So we're gonna have something like this with a plus charge, and then water next can come and attack in a sequence. Okay, you know, you can attack now and then kick this out. Okay, it's very unstable with a plus sign over there. So it's gonna go another inversion of our stereochemistry. And now we're gonna form a wedge instead of dash, so it's back to our original. And then yes, we have a plus charge over here, but another water is gonna come and then clip up that, and then I mean, you get the idea. I'm not gonna, well actually I will draw it for you. Okay, so we have water, and then he's gonna come and grab the hydrogen and so on, and we're gonna have the R configuration of R2 octanol. So the more we have dioxane, our ratio of the pure S2 octanol is gonna decrease.